Hello everyone, we are solving problems on the Thevenin and Norton's theorem. In that, next question is find Thevenin and Thevenin across the AB for the following network. This is the given network. In the given question, what he is asking? The Thevenin voltage and Thevenin resistance across these two terminals. So the voltage across 8 ohms will give Thevenin voltage VOC, that is equal to Thevenin. So you can apply either nodal analysis or mesh analysis. If you apply nodal analysis, be careful with these 2 ohm resistor and this 2 ohm resistor because these are connected in ground, that is at lower terminals. So it is better to apply mesh analysis. Let it be loop A, loop current 1, and let it be loop B, this loop current I2. Okay, apply mesh analysis or write mesh equation for loop A. So what you are getting? All sources equal to passive elements. So here what is source? 6 volts. The current is leaving from the source. We can take it as positive. 6 is equal to, here it is 2i1. Here this is common to this loop and this loop. So 8 into, so current is downwards and this current is upwards. Both are in opposite direction. So i1 minus i2. Coming to this 2 ohms, 2i1. So what you are getting? 12i1 minus 8i2 is equal to 6. Let it be equation 1. Now write mesh equation for loop B. So for this loop there is no sources. Okay, there are no sources. So sources are 0. So 0 is equal to, so this is 2i2 plus, for this 8i2, for this plus 2i2, for this 8 ohms it is upward direction, it is downward direction, both are in opposite direction. So plus 8 into i2 minus i1 minus 8i1 plus 20i2 is equal to 0. Equation 2. If you solve these two equations, you will get i1 is equal to 15 by 22 amps and i2 is equal to 3 by 11 amps. Okay, now we want voltage across this 8 ohms. This 8 ohms will become Thevenin voltage. So what is voltage across 8 ohms? V Thevenin is equal to 8i2. Okay, here current is entering here, so it is 8i2. So 8 into 3 by 11. V Thevenin is equal to 24 by 11 volts. Or you can apply nodal analysis. So let it be node V1. These 3 resistors are connected in series, so you can apply voltage division rule. Once if you know the voltage across this 8 ohms and this combination is connected in parallel. Okay, so you can apply node voltage only here. Write the node equation for V1. Okay, if you write the node equation for V1, what we are getting? V1 minus 6 by, okay, entire this branch. If you take this is reference node, entire this branch. So this 2 plus 2, 2 plus 2 plus V1 by 8 plus V1 by entire this branch 2 plus 8 plus 2, 12 volts, 12 ohms equal to 0. If you solve this, you will get V1 is equal to 36 by 11 volts. Now by voltage division rule, so this is 32, from here to here 32 volts, sorry 36 by 11 volts. So these 3 are connected in series, so you can apply voltage division rule. So what is VThevenin now? Same impedance 8 divided by, what is total impedance? 2 plus 8 plus 2, 12 into total voltage is V1, 36 by 11 ohms, 11 volts. So if we solve this, VThevenin is equal to 24 by 11 volts. Okay, in both the cases we got same answer. Now to find RThevenin, replace this voltage source with short circuit and find open circuit resistance. So then circuit becomes like this. Okay, here this 2 ohms and 2 ohms are in series and resultant is connected to 8 ohms in parallel. Okay, so let it be R1. So 2 ohms and 2 ohms are in series and resultant is connected to 8 ohms in parallel. So what is R1 now? R1 is equal to 8 into 2 plus 2 by 8 plus 2 plus 2. It will gives 8 by 3 ohms. Okay, the circuit becomes like this. Now again this 2 ohms, 8 by 3 ohms and 2 ohms are in series and there this resultant is connected to this 8 ohms in parallel. So what is R Thevenin now? R Thevenin is equal to 2 plus 8 by 3 plus 2. So if resistors are connected in series, the equivalent is summation of 3 resistors into 8 divided by 2 plus 8 by 3 plus 2 plus 8. If you solve this, you will get R Thevenin is equal to 40 by 11 volts. If you want to find out Norton current, I Norton is equal to V Thevenin by R Thevenin. So V Thevenin is 24 by 11, 40 by 11. I Norton is equal to 0.6 amps. Next question is, in the following figure, the network contains several resistors and several independent sources. If the current I equal to 3 amps, then the resistance is 0 ohms. If current I equal to 1.5 amps, then resistance is 2 ohms. Then determine current I when R equal to 4 ohms. This is the given data. This network contains several resistors and several independent sources. If current I equal to 3 ohms, R is 0 ohms. That means if R equal to 0 ohms, current is 3 amps. If R equal to 2 ohms, current is 1 amps. So I am replacing this entire network with Thevenin equivalent. Then circuit becomes like this. If R is 3 ohms, if R is 0 ohms means short circuit. Okay, this is short circuit. If it is short circuit, what is the current? 3 amps. Okay, if R is 0 means short circuit. If it is short circuit, current is 3 amps. Now from this, what is V Thevenin? V Thevenin is equal to 3 into R Thevenin. Okay, let it be equation 1. Now if R equal to 2 ohms, then what is current? 1.5 amps. Now redraw the circuit. So this is the circuit. If R equal to 2 ohms, the current flowing through R is 1.5 amps. So what is V Thevenin now? V Thevenin is equal to 2 resistors are connected in series. So total current is 1.5 amps. R Thevenin plus 2. Here R Thevenin is 3 R Thevenin. Here V Thevenin is 3 R Thevenin. Here V Thevenin is 1.5 into R Thevenin plus 2. So both are equal. So if we equate these two equations, 3 R Thevenin is equal to 1.5 into R Thevenin plus 2. If you solve this, you will get R Thevenin is equal to 2 ohms. Now from 1 or 2. So what is V Thevenin? V Thevenin is equal to, from 1 it is easy. So 3 into 2 is 6 volts. Now what is the question? If R equal to 4 ohms, then what is current I? Okay. Now what is I? I is equal to 6 by 2 plus 4. 6 by 2 plus 4. Because these two are connected in series. So the equivalent is 2 plus 4, 6. So voltage by resistance will give you current. So 6 by 6 is equal to 1 amps. So what is I? I is equal to 1 amp. In the next video, we will discuss some more problems on this concept. Thank you for watching.